Hello dear students, welcome to the NEET World. I am Vinay, Physics faculty. Today I am going to discuss about the NEET 2025 question paper. And we are going to discuss the first question, that is, a microscope has an objective of focal length 2 cm and eyepiece of focal length 4 cm and tube of length 40 cm. So length of the tube is 40 cm and focal length of objective they given. The focal length of objective is 2 cm and focal length of eyepiece is 4 cm and they given length of the tube. That length of the tube is 40 cm. And they given the distance of least vision of the eye is 25 centimeter. So the distance of least vision is taken as D, which is taken as 25 centimeter. We know this value. Anyway, they given in the question also. Then they're asking the magnification of the microscope. We have the formula for magnification of microscope. That magnification of microscope is M is equal to L by F naught multiplied by D by Fe. So on substituting these values, we can substitute 40 by F naught is 2 and D, where D is the distance of least vision, which is taken as 25 divided by Fe, that Fe is 4 centimeter. Then we can cancel 4 ones, 4 tens and 2 ones, 2 fives. 25 fives are 125. So option 2 is correct. Then we'll go for the next question. So this was the second question. In a certain camera, the combination of 4 similar thin convex lenses are arranged. So there are 4 thin convex lenses are arranged coaxially or axially in contact. So we kept 4 lenses axially in contact. Then the power of the combination and the magnification in comparison to the power. So they're asking the total power of this combination and they're asking the magnification. So total magnification. And what is the power of each lens? Means the power of each lens is P. So the power of each lens is P. Then we have the formula for effective power when the lenses are kept coaxially, that is P1 plus P2 plus P3 plus P4, which can be taken as 4P. And similarly, for magnification, we have one more formula, that is magnification, total magnification or effective magnification is equal to M1 multiplied by M2 multiplied by M3 multiplied by M4. So all are having the same magnification, which is equal to M. Then M times, so 4M is the answer. Then we'll go for the next question. Yeah, the next question, question number 3. An oxygen cylinder of volume 30 liter has 18.20 moles of oxygen after some oxygen withdrawn from the cylinder. For suppose I'll take it as a cylinder. So this cylinder contains 18.20 moles of oxygen. Now after some oxygen is withdrawn from the cylinder. So we are taking some oxygen from the cylinder. Its Gauss pressure drops to 11 atmospheric pressure. So they given the Gauss pressure drops to 11 atmospheric pressure at a temperature of 27 degrees centigrade. So temperature is given as 27 degrees centigrade. So at a temperature of 27 degrees centigrade, the Gauss pressure drops to 11 atmospheric pressure. Then they're asking the mass of the oxygen withdrawn from the cylinder is nearly equal to. So we have to find out how much amount of oxygen or how much mass of oxygen is withdrawn from the cylinder or removed from the cylinder. So for this, first let us find out what is the pressure, because they given the Gauss pressure drops to 11 atmosphere. So we have one formula, that is Gauss pressure P is equal to pressure minus atmospheric pressure. Okay, pressure of a gas minus atmospheric pressure. This Gauss pressure drops to 11 atmospheric pressure. So they given it drops to 11 atmospheric pressure, that is equal to P minus P naught, or the actual pressure is equal to 12 P naught. So 12 P naught is the actual pressure of the gas. And the given temperature, what is the temperature value? Means 27 degrees centigrade. If you can convert into Kelvin, we can add 27 plus 273, which is equal to 300 Kelvin. This is the temperature. Now we will find the number of moles at this temperature. If we find the number of moles at this temperature and at this pressure, then we can able to find out how much amount of moles gone out of this container. From that we can able to measure the mass of the gas. So here, first at this pressure and at this temperature, because here the pressure drops to 11 atmospheric pressure, gauge pressure drops to 11 atmospheric pressure and at a temperature of 27 degrees centigrade. Now we are going to calculate at this pressure, at this temperature, how many number of moles are present. For that, I will use the relation ideal gas equation. So what is that ideal gas equation? Means PV is equal to nRT. Now what is the pressure of the gas? Means 12 atmospheric pressure. So 12 into, we know that 1 atmospheric pressure is equal to 1.01 into 10 to the power of 5 Newton per meter square or Pascal. Already they given that value. So volume. So what is the volume of the cylinder? Means 30 liter. If you convert into meter cube, 30 into 10 to the power of minus 3, and that is equal to N. Number of moles, I will take it as N, and R value they given 100 by 12. So R value is 100 by 12 and they given temperature. The temperature is 300 Kelvin. Sorry. That is equal to N into R value 100 by 12 multiplied by 300. So if we cancel, we'll get the N value, that is number of moles. So on cancelling 10 to the power of minus 3 and 10 to the power of plus 5, it will be cancelled by 10 to the power of plus 2 times. And here 10 to the power of plus 2 and 2 zeros will get cancelled. And here this will be 10 times. And bring this to the left hand side. Then number of moles is equal to 12 into 12 multiplied by 1.01 whole divided by 10. So it will be approximately 12 12s are 144. So 12 square is 144. Approximately you will get 14.46 or 5. So if you multiply, approximately you will get 14.5. So this is the number of moles left. Now how many number of moles escape out of this cylinder we are going to calculate. So, or we can say number of moles. Okay, number of moles. We can say withdrawn. Okay, the number of moles withdrawn. So the number of moles withdrawn is equal to, initially we have 18.20 number of moles, and now how many moles of the gas is left means 14.5. So if you take approximately, this value will be 5 and this is 6 point, this is 4, you will get 7 minus 3, 7 minus 4 which is equal to 3. So number of moles left is 3.65. Then we have to find out the mass of the oxygen escape out of the cylinder. For that we will use one more relation. What is that? Means number of moles is equal to mass by gram molecular mass. Then mass M is equal to number of moles is equal to 3.65. I'll bring this to the left hand side, and gram molecular mass of oxygen is 32. So gram molecular mass of oxygen is how much? 32. If you multiply these two, you will get approximately 116 grams, or you can say it as 0.116 kilograms. This is the answer. Now we'll go for the next question. Yeah. So this was the question from alternating currents. Question number 4. This was the question from alternating currents. So to an AC power supply, 200 volts at 50 hertz and a resistor of 20 ohm and a capacitor of reactance 25 ohm and an inductor of reactance 45 ohm are connected in series. So here we are connecting a resistor and we are connecting an inductor and we are connecting a capacitor in series. And these are connected to a battery of potential 220 volts of frequency 50 hertz. Okay, of frequency 50 hertz. And they given resistance of the resistor which is equal to 20 ohm and reactance of the capacitor. That reactance of capacitor is taken as XC which is equal to 25 ohm, and inductor reactance or reactance of the inductor they given, so that is equal to 45 ohm. Now what we have to find out? we have to find out the corresponding current in the circuit as well as the phase angle between them. To find out the corresponding current, first let us find out the impedance. So we know that impedance Z is equal to under root of R square. We have this formula R square plus XL minus XC whole square. That can be taken as the resistance value is 20, which is equal to 20 square, plus XL minus XC, which is equal to 45 minus 25 whole square. The 45 minus 25 whole square is 20 whole square. So 20 whole square plus 20 whole square under root, which is equal to 20 root 2. This will be the value of Z. And how to find out the current means we have the formula V is equal to IZ or I is equal to V by Z. And the value of the current is 220, potential is 220 volts, and the Z value which is equal to 20 root 2. Now you can cancel 0 and 0, and you can cancel this is approximately 11 times. So we have the 11 root 2. So if you multiply 11 into root 2 value is 0.707. So if you multiply with this, approximately you will get 7.8 amperes. But here two options are there. And even we have to find out the phase angle also. So how to find out the phase angle means we have the formula tan phi is equal to XL minus XC by R. That implies that is equal to XL value is 45 and XC value is 25. 45 minus 25 is 20 divided by resistance of the resistor is 20. We can cancel both, which is equal to 1. So tan phi is equal to 1. Then that implies phi is equal to 45 degrees. So option 2 is correct. Then coming to the next question. Question number 5. So this was the question based on the atoms or modern physics problem. Based on the modern physics, we have this problem. So this question is a model of quantized motion of an electron in a uniform magnetic field. So an electron is moving in a uniform magnetic field. That magnetic field is B. States that flux passing through the orbit of the electron. So what is the flux linked with the orbit of electron means? The flux linked with the orbit of electron is NH by E. So this is the flux linked with the magnetic flux linked with the orbit of electron, where N is an integer and H is a Planck's constant and E is the magnitude of electron charge. According to the model, the magnetic moment of the electron in its lowest energy state will be. So lowest energy state means, please remember, N value is equal to 1. So for lowest energy state, N value is equal to 1. Now, how to solve this problem? We have the formula for magnetic moment. The magnetic moment formula is I into A, where I is the current and A is the area. Now, here the electron is revolving in the circular path in the external magnetic field. Now here the electron is revolving in the circular path in the external magnetic field. Now whenever the electron is revolving in the circular path, what should be the current associated with this electron? So to find out the current, we have the formula I is equal to Q by T. And we are going to find out what is the current associated with this revolving electron. For that, I'll take time or distance. The distance is equal to speed into time, or speed is equal to distance by time, or we can say distance is equal to speed into time. So distance is equal to speed into time. Now let us suppose I'll take speed of the electron as u and time I'll take it as t, and the distance traveled by the electron for one rotation, that is equal to 2 pi r, which is equal to circumference of the circle. Then time period t is equal to 2 pi r by u. And what will be the area associated with this electron? Is the area associated with this electron orbit is pi r square. This is the area. Now if I substitute this value in the equation of current, then we can say I is equal to, I'll take electron charge as E divided by T value is 2 pi r by u, that u will goes to the numerator. So this is the current. Then from this I can write magnetic moment M is equal to I value is EU by 2 pi r, and area associated with this revolving electron is pi r square. So I'll take it as equation number 1. And they given one more thing in the question. What is that? Means they given the magnetic flux linked with this revolving electron, or else with that loop. So we have the formula for magnetic flux, that is equal to magnetic field into area. So we can write like this. So magnetic flux is equal to magnetic field into area. But they given magnetic flux value as NH by E. So they given the magnetic flux value as NH by E. So we can write NH by E is equal to B into A can be taken as pi r square. But for lowest energy level, they asked for lowest energy level n is equal to 1. So if I substitute n is equal to 1, then we have the magnetic field B, or else I'll write pi r square. So that pi r square is equal to NH by EB. Can I write like this? Yes. Now substitute this pi r square value in the equation number 1. So from equation number 1, we can say magnetic moment M is equal to EU by 2 pi r multiplied by, this is NH by, or N value is 1 here. So N value is 1 here. So which can be taken as H by E multiplied by B. But we can say one more thing. When an electron is revolving in the circular path in the external magnetic field, then we can say magnetic field or radius of the circular path is given by mv by bq. So from this, if you substitute the r value in this equation, then magnetic moment m is equal to EU divided by 2 pi. R value is mu. Here the velocity is taken as u. Mu by bq into h by eb, or else this charge is also taken as e. This charge is also taken as e, be. So we can cancel b and b, and we can cancel one e and e, and you can cancel even u and u also. Then the final answer is magnetic moment m is equal to EH by 2 pi m. So this is the answer. That is option 2 is correct. HE by 2 pi m. Now we are going to discuss the next question. Question number 6. Yeah. This was the question from capacitors topic. So they given the plates of parallel plate capacitor are separated by a distance d. So I'll take this as a capacitor plate. The plates of this capacitor is separated by a distance d, and two slabs of dielectric constant K1 and K2 with thickness 3d by 8. So 3d by 8 means obviously it will be less than this, and d by 2, which means that the second slab is exactly half of the distance of first slab. I mean the distance between the two capacitor plates respectively are inserted in the capacitor. So one dielectric slab, initially if I take the capacitance of this capacitor, this is an air-cooled capacitor. So that air-cooled capacitor capacitance I will take it as C0, which is equal to epsilon naught A by D. This is the capacitance of air-cooled capacitor. And inside this we are keeping two dielectric slabs. The first dielectric slab of thickness 3d by 8 and second dielectric slab of thickness d by 2. So the second dielectric slab of thickness d by 2. And the dielectric constant of first one is K1 and the dielectric constant of second one is K2. So this is the information. Now due to this, the effective capacitance becomes 2 times larger when there is nothing between the plates, which means that if I take the capacitance of capacitor in air, that is equal to C0. Now after introducing these two dielectric slabs, the new capacitance becomes 2C0. Okay, the new capacitance becomes 2C0. Now for suppose if I take it as one terminal, if I take it as another terminal, I'll take it as terminal A and I'll take it as terminal B. This look like two capacitors with dielectric connected in series. Now first I am going to calculate capacitance of this first dielectric. The capacitance of this first dielectric is taken as C1, which is equal to, we have the formula for capacitance of capacitor with dielectric, that is taken as K1 epsilon naught A by, here the thickness of the dielectric slab is 3D by 8. So which can be taken as 8 K1. We can say epsilon naught A by D as C naught. So K8 C1, sorry, C naught K1 divided by 3. Because epsilon naught A by D, you can take it as C naught. In the same way, what will be the capacitance of this second dielectric means, that is C2, that C2 is equal to K2 epsilon naught A by, this is D by 2. Then 2 will goes to the numerator, and epsilon naught A by D, once again you can take it as C naught. So then this value will be 2K2 C naught. Yeah. So this value will be 2K2 C naught. Now the C1, C2, it look like these two capacitors with the dielectric, it look like connected in series. So what is the effective capacitance when two dielectrics connected in series means, that C effective is equal to C1, C2 multiplied by C1 divided by C2. So then C1 value is 8K1 into C naught divided by 3 multiplied by C2 value 2K2 C naught divided by C1 plus C2. That C1 plus C2 is 8K1 C naught by 3 plus 2K2 C naught. But they given this effective capacitance becomes 2 times. So in the question they given, the effective capacitance becomes 2 times larger than when there is nothing between the plates. So therefore, you can write this C effective as 2 C naught. So we can write this C effective as 2 C naught. The 2 C naught is equal to, so that 2 C naught is equal to, you can write 8 to the 16, 16 by 3, this is K1, K2, multiplied by C naught, and C naught is C naught square, divided by, from these two you can take 2 C naught as common. If you take 2 C naught as common, then first term will be 4K1 by 3, plus second term will be K2. Then we can cancel one C naught and C naught here, another C naught and C naught here, and you can cancel 2 ones to 8 times, and we can cancel 2 ones to 4 times. Therefore, I'll bring this to the left hand side. Then we can say 4K1 by 3 plus K2 to 4 by K1 K2. So we can cancel, we can do the cancellation now. But here one more concept they given, K1 equal to 1.2 K2. So I'll use the next slide. So they given K1 equal to 1.25 K2. So from this we can write, I'll write in a fraction. So 1.25 can be taken as 125 by 100 into K2 for easy calculation, which is equal to K1. Cancel 25 5s and 25 4s. Then K2 can be taken as 4 by 5 times of K1. And we'll substitute the value in the previous equation. This equation will substitute. So what is that equation means? 4K1 by 3 plus K2, which is equal to 4K1 K2. 4 by 3 K1 K2. So 4K1 by 3 plus K2 is equal to 4 by 3 K1 K2. Now if I substitute the K2 value here, you can write like this, 4K1 by 3 plus K2 value is 4 by 5 K1. That implies that is equal to 4 by 3 K1 into K2 value is 4 by 5 K1. So we can take 4K as common and you can cancel. So if I take 4K1 as common, and the LCM will be 1 by 3 plus 1 by 5, which is equal to 3 into 5, and the numerator will be 5 plus 3, which is equal to 4 by 3 K1 multiplied by 4 by 5 K1. So you can cancel 4K1, 1 4K1, we can cancel 3 into 5 and we can cancel 3 into 5. Then 8 is equal to 4K1 or K1 is equal to 8 by 4, which is equal to 2. So K1 value is 2. This question is little bit lengthy. So it is approximately, we can take 2.33. Because we got the value like this, the reason here I taken this approximately, 4 by 5 instead of using the fraction. And we'll go for the next question. Now we are going to discuss the next question, question number 7. That is, this question is from the oscillations. In an oscillating spring of mass system, a spring is connected to a box filled with sand. As the box oscillates, sand leaks out slowly out of the box vertically. So the average frequency omega t and average amplitude at of the system changes with time t. Which of the following options schematically depicts the changes correctly? Now here we have a spring mass system. So this spring is connected to a box of mass m, which is filled with the sand. Okay, this is filled with the sand. As the sand leaks out of the box slowly, then mass of this box decreases and this box starts oscillating in the vertical direction. Okay, this box oscillates in the vertical direction like this. Then we have the formula for angular frequency of the box, that is omega is equal to under root of k by m, or we can say omega is inversely proportional to square root of m, or m is inversely proportional to omega square. As the mass of the sand is coming out of the box, its mass decreases, then angular frequency value increases. So with respect to time, mass is going to decrease and the angular frequency is going to increase. Then out of these 4 options, we can eliminate this option because here the angular frequency decreases with time. So we can eliminate this option and our option may be of 1, 2, 3 options. We are going to do this. Now, if the mass of this sand is coming out of the box, then it oscillates with the decrease in the energy. That is nothing but it looks like a damping oscillations. In case of damped oscillations, the energy of the oscillator decreases. And that energy is directly proportional to square of amplitude. So in case of damping oscillations, the energy of oscillations decreases gradually and that energy is directly proportional to square of amplitude. So then we can say if energy decreases, then amplitude will also decreases. Then which option correctly predicts this means? Option 2. So in option 2, angular velocities keep on increasing and A, amplitude is decreasing. So option 2 is correct. Then we are going to discuss the next question. Yeah, the next question, a balloon is made up of material of surface tension S and its inflation outlet from where gas is filled in it has a small area A. So a balloon has a small outlet, okay, a balloon has a small outlet from where we are going to fill the gas, okay, small outlet where we are going to fill the gas. And the surface tension of the balloon is taken as S. And the area of this small outlet is taken as A. So capital A is the area of outlet and it is filled with the gas of density rho, has a spherical radius capital R. So radius of this balloon is taken as capital R. When the gas is allowed to flow freely out of it. So when the gas is flowing freely out of it, its radius decreases from R to 0. So whenever the air comes out of the balloon, the radius of the balloon is keep on decreasing and finally the R becomes how much? 0 in a time t. If the speed of the gas coming out of the balloon depends on R as R power A, then T proportional to S power alpha, A power beta, rho power gamma and R power delta. So we are going to do this problem by using the dimensional analysis method. So based on this equation, the time taken to escape the gas completely out of the balloon, they given it is proportional to S to the power of alpha, where S is surface tension, and A power beta, where A is area of this outlet, and rho is the density of gas inside it, power gamma, and r is the radius of the balloon, power delta. Now we have the formula for surface tension, which can be taken as force per unit length, and the dimensional formula for the force is ml t power minus 2 divided by, and length dimension formula is L, cancel L and L. The dimensional formula for the surface tension is m t power minus 2. If you remember that directly, you can substitute it. And time can be taken as m power 0, L power 0, t power 1 in terms of dimensional analysis. It is proportional to surface tension. Dimensional formula is m t power minus 2 whole power alpha, and area dimensional formula is L square whole power beta, and rho is the density. Density is nothing but mass by volume. So then mass is m, volume dimensional formula is L cube. So we can write m L power minus 3 whole power gamma So ml power minus 3 whole power gamma, and radius is nothing but length only. We can measure the radius in terms of meters. So which is the dimensional formula for length. We can write r power delta. Then by equating the powers, we can able to solve this question. So how I am going to equate this powers means m power 0, L power 0, t power 1, which is proportional to, you can take here m power alpha and here m power gamma, then it looks like a power m into a power n. The formula is a power m plus n. So based on that formula, if I can do the calculation, here you will get m power alpha plus gamma. So this value will be m power alpha plus gamma. And similarly, if I take the powers of L, this is L power 2 beta, L power 3 gamma, L power delta. So L power 2 beta plus L power, into L power minus 3 gamma into L power delta. So as the bases are equal, you can add the powers here. So if you add the powers, then you will get L power 2 beta minus 3 gamma plus delta. And similarly, if I take the powers of time, here only one time term is there. You can write t power minus 2 alpha. Now on left hand side and right hand side, as the bases are equal, we can equate the powers. If you equate the powers, alpha plus gamma is equal to 0. That implies we can say gamma is equal to minus alpha. And from the second equation, we can write 2 beta minus 3 gamma plus delta is equal to 0. This is the second equation. And third equation, we have minus 2 alpha, so is equal to 1, or alpha can be taken as minus 1 by 2. So if alpha is minus 1 by 2, then gamma will becomes plus 1 by 2. Now substitute this alpha gamma in the value of beta, in the second equation. If you substitute this in the second equation, you will get 2 beta plus minus 3 into gamma, two beta minus 3 into gamma value is plus 1 by 2 plus delta is equal to 0. We can write like this. Then we can write 2 beta plus gamma is equal to 3 by 2. Now based on the options, you can solve this problem. So we have alpha equal to minus 1 by 2, gamma equal to plus 1 by 2. So here we have alpha equal to minus 1 by 2, gamma equal to plus 1 by 2. So by using this, I can able to calculate the beta as well as gamma delta also. So if I take beta value as minus 1, then minus 2 plus gamma is equal to, delta equal to 3 by 2. Then delta is equal to 3 by 2 plus 2, which is equal to 7 by 2. So this option exactly suits. So we can do the rest of the problem based on the options. Okay. So by calculating alpha gamma itself, we can decide the value of beta as well as the delta. And you can calculate the A value by using the velocity dimension formula. So velocity is Lt power of minus 1. So based on that, you can calculate. And the next question number 9. An unpolarized light beam traveling in air is incident on the refractive index, medium of refractive index 1.73 at Brewster's angle. Then remember, whenever an unpolarized light is going to incident on, okay, whenever an unpolarized light is going to incident on the material transparent medium, then if it incidents with the polarizing angle or the Brewster's angle, the reflected light should be completely polarized. Clear? The reflected light should be completely polarized, whereas the refracted light may be a partially polarized. So reflected light should be completely polarized or perfectly polarized. And if I take refractive index of this medium, the refractive index of this medium is 1.732. Then we have the formula for Brewster's angle. IP is equal to tan inverse of mu, or tan mu is equal to IP. So IP is equal to tan inverse of 1.732. Clear? So from this, when you will get tan value as 1.732 means we can write it as root 3. When you will get the tan IP value as root 3 means, so tan IP is equal to, or tan IP equal to, you can write it as root 3. So you will get root 3 value when IP is equal to 60 degrees. So the answer will be, the polarizing angle should be 60 degrees. At this 60 degrees, it will be completely polarized. So option 1 is correct. The reflected light is completely polarized and the angle of refraction is close to 60 degrees. And if I take the second option, the reflected light is partially polarized, it is wrong, because reflected light should be completely polarized. Both reflected and transmitted lights are perfectly polarized, it is wrong. And transmitted light is completely polarized. Actually, transmitted light contains the partially polarized light. It is not perfectly polarized, it is partially polarized. Then we are going to discuss the next question. Question number 10. And this is the problem from gravitation. They given a body weighs 48 Newton on the surface of the earth. So on the surface of the earth, the weight of the body, so the weight of the body on the surface of the earth is 48 Newton. Then the gravitational force experienced by the body due to the earth at a height equal to 1/3 of the radius. So height is equal to 1/3 of the radius. They are asking at a height h is equal to r by 3 of the earth. Then to find out the gravitational field intensity or acceleration due to gravity at a height, we have the formula gh is equal to g into r by r plus h whole square. So the value will be r by r plus h whole square. Students, you may have one doubt, sir, why can't we use this formula gh is equal to g into 1 minus 2h by r? Actually, this formula we can use for the lesser heights. More precisely, if the height less than or equal to r by 10, then only you have to use this formula. Okay, fine. So we can use that formula to find out this problem. So what is the acceleration due to gravity at that height means, we can write gh is equal to g into, this is r by r plus r by 3 whole square. So that can be taken as 3r by 4r whole square into g. Because if I take LCM will be the 3, and the numerator this will becomes 3r plus r, which is equal to 4r. Cancel these two. Then acceleration due to gravity at a height is equal to 9 by 16 times of g. Then weight at a height is equal to m into 9 by 16 times of g. Okay, so take it as equation number 1 and take it as equation number 2. Then we can divide weight at a particular height divided by weight on the surface of earth is equal to, weight at a particular height is equal to mg into 9 by 16 divided by weight at a particular, on the surface is mg. Cancel mg and mg. Then bring this to the right hand side. Then weight at a particular height is equal to, then weight at a particular height is equal to 9 by 16 times of, I'll bring this weight to the right hand side, that is weight on the surface of the earth, which is equal to 48 Newton. Then 16 ones, 16 threes and 9 threes are 27. So 27 Newton is the weight at a particular height. What is that height means? 1/3 of the radius of earth. Now we are going to discuss the next question. This was the question based on the modern physics and atoms chapter. So here they given a particle of mass m is moving around the horizon with constant force pulling towards the horizon. So a particle of mass is moving around the horizon with constant force pulling towards the horizon. If the Bohr's model is used to describe its the motion, the radius of the nth orbit and the particle speed v of the orbit depends on n as. For suppose a particle of mass m is revolving in a circular orbit and this force on this particle is always towards the horizon. That force is taken as centripetal force. Okay, that force is taken as centripetal force, and this force they given constant according to the given question. Then we have the formula for centripetal force, F is equal to mv square by r. Okay, this is a formula for centripetal force, mv square by r. Now it is moving with a particular speed. I'll take the speed of the particle as v. Okay, it is moving with a particular speed, it is v. Now we have to find out the relation between the radius and the number of orbit, nth orbit they given, and velocity and the nth orbit. For that, I will use the quantization principle. Okay, according to the quantization, Bohr's second postulate, the quantization principle, mvr is equal to nh by 2 pi. Okay, mvr is equal to nh by 2 pi. From that, I'll write r value. So r is equal to nh by 2 pi into mv. So I'll bring this mv to the right hand side. Then we'll get nh by 2 pi into mv. Substitute this value in the force equation. If I substitute this value in this equation, then F is equal to mv square by r value is nh by 2 pi mv. Or v will goes to the numerator and I'll bring this n to the right side. And if I take n to the right side, then n is equal to, you can write it as m will goes to the numerator, you can write 2 pi m square v cube. Because if m goes to the numerator, already here m is there, m into m is m square, and already here v square is there, here v is there. So v cube divided by h into f. Here 2 pi is a constant, m is mass of the electron or the particle which is constant, and h is Planck's constant, and the given force also constant. Then n is proportional to v cube, or v is proportional to n to the power of 1 by 3. Now in the same way, from this equation, from equation number 1, we can say v square is proportional to r. Then v square value is n to the power of, or v square is v is proportional to n to the power of 1 by 3. Then you can write v square as n to the power of 2 or 1 by 3 whole square. Because v is proportional to n to the power of 1 by 3. Because here v is proportional to n to the power of 1 by 3, then if I substitute n power 1 by 3 whole square proportional to r, or r proportional to n to the power of 2 by 3. So v is proportional to n to the power of 1 by 3, r is proportional to n to the power of 2 by 3, option 3 is correct. Then we'll go for the next question. This question is also from the modern physics, that is dual nature of radiation. So a de Broglie wavelength of an electron orbiting in the n equal to 2 state of an hydrogen atom is close to. We have the formula for, let us say the electron is revolving around the second orbit. So electron is revolving in the second orbit. So if electron is revolving in the second orbit, okay, if electron is revolving in the second orbit, then the distance covered, if I take this radius as r, then the path difference, or you can write the distance as 2 pi r, which is taken as n lambda. Okay, 2 pi r which is taken as n lambda. And here r they given radius of the Bohr's orbit. And radius of the Bohr's orbit value is, we know that radius of the Bohr's orbit is r is equal to 0.529. Are you clear? So they given 0.052 angstrom it is, but they given in nanometer. So 0.529 into n square by z angstrom. So they given in nanometer. So how they given this value in the nanometer means, in the nanometer they given this radius value as 0.052 nanometer they given. So nano means in the value of 10 to the power of minus 9 into n square by z, where n is number of the orbit and z is the proton number. Then if I substitute here, multiplied by r value is 0.052 into 10 to the power of minus 9. They given second orbit, they given second state. So second orbit, for second orbit n square value is 4 by, they given hydrogen atom. For hydrogen atom proton number is 1. So divided by 1, which is equal to, in which orbit it is revolving means it is revolving in the second orbit. If it is revolving in the second orbit, n equal to 2, and the wavelength is taken as lambda, so that wavelength is taken as lambda. Then we can cancel, and 2 and 2, and if you multiply 3.14 into 0.052 multiplied by 4 into 10 to the power of minus 9, if you take this value, you will get 0. But after multiplication, you will get 0.67 into 10 to the power of minus 9 or 0.67 nanometer. This is the answer. So option 2 is correct. Then we'll go for the next question. Question number 13. So this was the question from the electrostatic potential. An electric dipole of dipole moment they given. So the dipole moment they given as P is equal to 5 into 10 to the power of minus 6 coulomb meter, is aligned in the direction of uniform electric field of magnitude 4 into 10 to the power of 5. So they given uniform electric field of magnitude 4 into 10 to the power of 5 Newton per coulomb. Now initially the dipole is in the direction of external electric field. So I will take it as external electric field, uniform electric field. So that's why I represented with the parallel lines. And the dipole, so dipole is aligned, initially dipole is aligned in the direction of external electric field. Then what should be the theta 1 value means, okay, what should be the angle theta 1 means theta 1 equal to 0 degrees. Because it is aligned within the direction of uniform electric field. Now they are given, the dipole is then rotated through an angle 60 degrees. Now we rotated the dipole through an angle 60 degrees with the electric field. Okay, with respect to the electric field. Then the change in the potential energy of the dipole is, we have the formula for potential energy of the dipole change, which is equal to minus P into cos theta 2 minus cos theta 1. So on substituting these values, you will get the required answer. Then energy stored U is equal to minus PE into cos theta 2. So we rotated through an angle 60 degrees. So 60 degrees means it will be 1 by 2, cos 60 is 1 by 2, minus cos 0 is 1, because theta 1 is 0, and this is cos 60 value is 1 by 2. Then U is equal to minus P into 1 by 2 minus 1 is, again it is minus 1 by 2. So after substituting these values, so minus into minus it is plus, and P value is 5 into 10 to the power of minus 6, and E value 4 into 10 to the power of 5 divided by 2, because here it is 1 by 2, cancel 2 1s, 2 2s, 5 2s are 10. So 10 into 10 to the power of 5, which is equal to 10 to the power of 6, and here we have 10 to the power of minus 6, both will be cancelled, then energy will be 1 joule. This is the answer. Then we'll go for the next question. Yeah, this is also the problem from modern physics, from dual nature of radiation. Question number 14. A photon and an electron of mass m have the same energy. The ratio of lambda photon to the lambda electron under de Broglie wavelength is. Always remember, if I take a photon, for a photon, always the energy is taken as E is equal to h nu, or you can write it as hc by lambda. Then for photon, okay, lambda photon is taken as hc by E. This is the lambda for photon. Whereas other than photon, if they given any particle, we can apply the de Broglie wavelength formula to find out the wavelength. We have the formula for de Broglie wavelength, lambda is equal to h by mv, but they given in terms of energy, we have the formula for energy E is equal to half mv square. So from that equation, we can write 2E is equal to mv square, or v square is equal to 2E by m, or V is equal to under root of 2E by M. So if I bring this square to the other side, it will become square root. So under root of 2E by M. Now if I substitute that value, then lambda is equal to H by M into V can be taken as under root of 2E by M, or if I bring this mass is also under the root, then this value will becomes H by under root of 2E into M. Okay. So take it as equation number 1, and take it as equation number 2. This is for electron. Then lambda electron is equal to H by under root of 2E into M. So take it as equation number 2. Then they're asking lambda photon by lambda electron. Okay, they're asking lambda photon by lambda electron. So lambda photon by lambda electron can be taken as Hc divided by E multiplied by, it will becomes inverted. If it becomes inverted, you can write under root of 2em divided by h, because it is a mixed fraction. Again, it will goes to a numerator. You can cancel h and h, and if I write this lambda p by lambda e, if I bring this e also under the root, okay, if I bring e also under the root, then c into under root of 2m by e, because if e also, if you can write under the root, you can write 2em divided by e square. So if I take this e under the root, it will becomes e square. Then we can cancel one e and one e here, 2m by e under root. So option 3 is correct. Then the next question is, a sphere of radius r is cut from a large sphere of radius 2r. So this is a large sphere. So radius of this large sphere is 2r. From this 2r, a small sphere is cut whose radius is smaller, which means the diameter will be 2r. Okay, so from the radius of the sphere 2r, a small sphere is cutted from it. Okay, small sphere is cutted from it. Radius of the small sphere is r. Okay, radius of the small sphere is taken as r. Okay, so first let us find out the mass of the actual sphere and mass of the removed sphere. Then how to find out the mass of the actual sphere means density into volume. Volume can be taken as 4 by 3 pi. What is the radius of the big sphere or actual original sphere means 2r, that is 2r whole cube. Because mass can be taken as density into volume, that volume can be taken as 4 by 3 pi r cube. R is taken as 2r here. So therefore, the initial mass is equal to, I will take it as mass initial, that initial mass is equal to 2 cube. 2 cube means 8 into 4 by 3 pi rho r cube. So this is the initial mass. Now I will calculate the mass of this removed part. Okay, I will calculate the mass of this removed part. So mass of the removed part, I will take it as mr. That mass of the removed part is equal to, we removed this mass from the same sphere only. So therefore density value doesn't change, density is rho into 4 by 3 pi r cube. Because removed mass radius is how much? R. Okay. So from this, I will divide initial mass by removed mass, or removed mass by initial mass. Removed mass is 4 by 3 pi r cube into rho divided by what is the initial mass means 8 into 4 by 3 pi r cube into rho. Cancel these two. Then removed mass is equal to initial mass by 8. So this is the removed mass and that is the initial mass. Now what is the question they ask means the ratio of moment of inertia of smaller sphere, that of the rest part of the sphere. Okay, fine. So the moment of inertia of smaller sphere as that of the rest of the sphere. If I take small sphere, that small sphere moment of inertia, I will take it as I1. Okay, small sphere moment of inertia, I will take it as I1. And they are asking about y-axis, which means that that small sphere is rotating about the tangent. Because it is y-axis, now the small sphere is rotating about the tangent. So they asked the ratio of moment of inertia of smaller sphere. about whom y-axis. So smaller sphere about y-axis can be taken as moment of inertia about the tangent. Okay. So first of all, find out the moment of inertia of smaller sphere about the center. Moment of inertia of smaller sphere about the center is 2 by 5 m dash r square. Because what is the mass of the small sphere means m dash. Okay, small sphere is nothing but removed mass. So then moment of inertia about the center ij is equal to 2 by 5 m dash or m removed can be taken as initial mass by 8 into r square. This is the moment of inertia about center. Then moment of inertia about the tangent is I is equal to ig plus ma square. Then ig value 2 mr square by 8 5s are 40 plus again what is the mass of this removed part means, okay, mass of the removed part means m by 8 into, and according to the parallel axis theorem the distance between the two parallel axes taken as a, in this case it becomes r, which is equal to mr square. Then for 40 and 8 LCM will be 4 tens, 4 twos, and 8 will be the LCM, or you can write like this 2 ones, 2 5s, 2 ones. So 40 will be the LCM. Okay, for 40 and 80 LCM will be 40, and first term is 2 mr square plus second term is 5 4s are 40, sorry 5 8s are 40, that is 5 mr square. So moment of inertia of the removed part I will take it as I1, that I1 is equal to 7 mr square by 40. This is the moment of inertia of removed part. Okay, this is the moment of inertia of removed part. Now, if I take moment of inertia of remaining part, so moment of inertia of remaining part is equal to initial moment of inertia whenever it is not removed, initial moment of inertia minus moment of inertia of removed part. Okay, this is remaining and this is removed. Then moment of inertia of remaining part is equal to, okay, moment of inertia of remaining part is equal to initial moment of inertia. Whenever the mass is not removed, the initial mass of the sphere is m and initial radius is 2r, then initial moment of inertia is 2 by 5 m into 2r square. Okay, minus what is the removed moment of inertia means, the removed moment of inertia is 7 by 40 mr square. So this is 7 by 40 mr square. Okay, so removed mass moment of inertia is, sorry, yeah, 7 by 5 mr square. Then you can write it as 2 2s are 4, 4 2s are 8, 8 mr square by 5. Okay, this will be 8 mr square by 5 minus 7 by 40 mr square. Okay, then we can say LCM will be once again 40, because for 5 and 40, what is the LCM means 5 ones, 5 8s, 8 5s are 40, so 40 is the LCM. Then 8 times it will be cancelled. The 8 times if it is cancelled, then 8 8s are 64. 64 mr square is the first term, minus second term is 7 mr square. Then this value will be 57 by 40 mr square. This is the moment of inertia of remaining part about the y-axis. Then in the question they asked moment of inertia of remaining part, sorry, smaller sphere to the rest of the part. Smaller sphere is 7 by 40 mr square. Just now we calculated, which is taken as I1, and remaining, I remaining is equal to, okay, I remaining is equal to, this is 57 by 40 mr square. Then cancel mr square and mr square, 40 and 40, then 7 by 57 is the answer. So option 3 is correct. The next question, it is from thermodynamics. two gases A and B are filled at the same pressure in separate cylinders with movable pistons of radius RA and RB on supplying equal amount of heat energy. So we are supplying the equal amount of heat energy and pressure of both the gases also same. PA is equal to PB. Pressure of both the gases are same and radius of both the pistons are RA and RB. This is the first piston. This first piston radius is RA. So radius of the first piston is RA. And I will take a second piston. The radius of the second piston is taken as RB. And both the cylinders are at same pressure on supplying equal amount of heat energy. We are giving the equal amount of heat energy to both the cylinders. Reversibly under constant pressure, the piston of gas A and gas B are displaced by 6 cm, 9 cm. Now this piston A is displaced by 16 cm. Okay, so gas A is displaced by 16 cm and gas B is displaced by 9 cm. Then they are asking the ratio of RA and RB if the change in internal energy is also same. Okay, now we'll use the thermodynamics first equation. What is that? Means dq is equal to du plus dw. Now according to the given question, they given same amount of heat energy, clear, same amount of heat energy given, equal amount of heat energy. So for first cylinder dq1 is equal to dq2 and they given same internal energy also same. So if the change in the internal energy is same, so change in the internal energy also same, then there will be different work done because here this piston A is displaced more and piston B is displaced less. Okay, piston B is displaced less. So work done will be different. So then work done by the gas A is equal to work done by the gas B. Because if you equate the heat energy given by the first gas, dq is equal to du plus dwa. Okay, dqa is equal to du plus dwa. And for the second cylinder, dqb is equal to dub plus dwb. They given equal amount of heat energy. They told same amount of internal energy. Then both will be cancelled. You will get work done by A gas is equal to work done by the gas B. Then we have the formula for work done. That work done is equal to pressure of gas A into change in the volume. So that is taken as, volume can be taken as area into length. So that area into length is taken as x1 or xa for the first gas, which is equal to work done for the second gas is pressure is PB. Okay, so work done formula is P into delta V. So dW is equal to P into dV. So I'll take P into that work done can be taken as A into, here the displacement is XB. But once again they given same pressure. So PA equal to PB. We can cancel both. And area of the first cylinder, okay, area of the first cylinder can be taken as pi RA square into XA is the displacement of first cylinder, which is equal to area of second cylinder can be taken as pi RB square into XB. Then cancel pi and pi. Then we have RA square by RB square, which is equal to XB by XA. So that implies RA by RB. That implies RA by RB is equal to under root of what is XB value means 9 centimeter, what is XA value means 16 centimeter. So under root of 9 by 16 is 3 by 4. This is the answer. A physical quantity P is related to 4 observations A, B, C, D as follows. That is P is equal to A cube B square divided by C into D power of 1 by 2. Because we can write under root of D as D power 1 by 2. The percentage errors in the measurement of A, B, C and D are 1%, 3%, 2% and 4% respectively. Then the percentage error in the quantity P is. Listen students, we can write the percentage error in A as delta A by A, which is equal to 1%. And similarly, percentage error in the B can be taken as delta B by B, which is equal to 3%, and delta C by C, which is equal to 2%, and delta d by d, that can also taken as 4%. To do this formula or problem, we have one concept called as error in power or error in exponent. That is, if z is proportional to a to the power of p, then we can write delta z by z, which is equal to p into delta a by a. We can use this relation. And if more than one quantity is there, one physical quantity is there, like z is proportional to a to the power of p, b to the power of q, divided by c to the power of r. In this case, we can write delta z by z is equal to, you can write it as p into delta a by a plus q into delta b by b. Generally, if c power r goes to the numerator, we will get c to the power of minus r. Then here we can expect minus r into delta c by c. But we have to always take that quantity as positive only, because error is always measured in positive. So if I bring this to a numerator, you will get plus r into delta c by c. Okay. So if I bring this to a numerator, then you will get z is proportional to c to the power of r. C to the power of r means we can write, c to the power of minus r, we can write minus r into delta c by c. But error is always taken as positive. That's why you have to take still plus delta c by c. So if I expand this problem in this formula, we'll get the equation like this. Delta p by p, which is equal to 3 into delta a by a, because here a power is 3 and b power is 2, so you can write 2 into delta b by b, plus you can write c power 1. C power 1 means 1 into delta c by c, plus it is d power 1 by 2, which can be taken as 1 by 2 into delta d by d. Then we have the percentage error of delta a by a, which is equal to 1%. Then we can write delta b by b is equal to 3 into 1% plus 2 into delta b by b. What is delta b by b means 3%, plus 1 into delta c by c, which is equal to 2%, plus 1 by 2 into delta d by d, which is equal to 4%. Then we can cancel 2 times here, and this is 3 plus 6 plus 2 plus 2, which is equal to 13%. This is the answer. And the next question, this is from waves. That is a pipe open at both ends. So pipe open at both ends means it comes under the open pipe. Okay. So a pipe open at both ends has a fundamental frequency f. So that fundamental frequency of this open pipe is f. Okay. The fundamental frequency of this open pipe is f. And we have the formula for fundamental frequency of open pipe. If I take open pipe fundamental frequency, in the fundamental frequency, the wave will be formed like this. Okay, the wave will be formed like this. So this is antinode and this is also antinode. Antinode to antinode distance is lambda by 2. That lambda by 2 is equal to L, or lambda is equal to 2L, or frequency mu is equal to V by lambda. So that fundamental frequency can be taken as V by 2L. So take it as equation number 1 for the open pipe. So the fundamental frequency of open pipe. Then in the question they told, the pipe is now dipped vertically in a water drum half of its length. If I take total length of the pipe as L, half of this length is immersed in water. Okay, then half of the length is immersed in water. Then what is the length of this air column means L by 2. Now, if this pipe is dipped in water, it looks like a closed pipe. Then the fundamental frequency of air column is now equal to, I'll take this fundamental frequency of f dash, because this closed pipe, it becomes a closed pipe. This is initially an open pipe. Now it is dipped in the water, it becomes a closed pipe. Now what is the fundamental frequency of closed pipe means f dash. That can be taken as f dash is equal to V by 4L. But what will be the length of the pipe means L by 2. Okay, because for closed pipe, this is a closed pipe. For closed pipe, what is the fundamental frequency means V by 4L. So V by 4L is the fundamental frequency. But what will be the L of this pipe means L by 2. Cancel 2 times. Then f dash is equal to V by 2L. And even initial frequency also f. Then we can say f dash is also equal to f. So option 2 is correct. Then we'll go for the next question, that is the kinetic energy of two similar cars A and B are 100 joules and 225 joules. So the kinetic energy of two similar cars are 100 joules and 225 joules. So then I'll take kinetic energy of first car is equal to 100 joules and kinetic energy of car B is equal to 225 joules. On applying the brakes, car A stops after 1000 meter. So the displacement of car A is taken as 1000 meter from the point where it stops the brakes, it applies the brakes, and displacement of the car B is equal to 1500 meter. If FA and FEB are the forces applied by the cars A and B. So FA is the force applied by the brakes of the car A and FB is the force applied by the brakes of car B. Then the ratio of FA and FB is. Now listen, whenever the car is going to stop, its final velocity is 0, then final kinetic energy of the first car is 0, or this is for car A, and final kinetic energy of car B is also 0 because both the cars are going to stop. Okay, so initial kinetic energy is 100 joules, final kinetic energy is 0. For car B, initial kinetic energy 225 joules, final kinetic energy is 0. And a given force and even displacement also, and we have to find out the ratio of the forces. So to do this problem, we can use the work energy theorem. According to the work energy theorem, change in kinetic energy is equal to work done. The change in kinetic energy can be taken as final kinetic energy minus initial kinetic energy is equal to work done can be taken as force into displacement. Now for car A, I'll take final kinetic energy as 0 minus initial kinetic energy is equal to 100, that is equal to force on the first car by displacement of first car. Okay, so take it as equation number 1. And similarly for the car B, final kinetic energy of car B is 0 and initial kinetic energy of car B is 225 joules, which is equal to force of the second car multiplied by displacement of second car. Take it as equation number 2. Then they're asking ratio of FA by FB. Then divide equation number 1 by equation number 2. Then you can get it as minus 100 divided by minus 225 is equal to, you can write FA into displacement of car A is 1000 divided by FB into displacement of car B is 1500. Then cancel minus and minus, 2 zeros and 2 zeros will cancel. 15 ones, 15s are 225, and you can cancel 1 0 and 1 0 here. Then FA by FB, which is equal to 10 by 15, which is equal to 2 by 3 is the answer. So option 2 is correct. Then coming to the next question, question number 20. Yeah. So this is the question from current electricity, and this question is based on the electrical circuit. Now let's look at this question. In this question they given one circuit diagram, and this is the circuit diagram they given here. So this part, look at the particular part A, B, C, D, E, F. It looks like Wheatstone bridge because I'll take this as R1, I'll take it as R2, I'll take it as R3, and I'll take it as R4. So first let us find out whether the Wheatstone bridge condition is satisfied or not. I'll take R1 by R2, that R1 by R2 is equal to 5 by 3, and I'll take R3 by R4. So R3 by R4 is equal to 2.5 divided by 1.5, which is equal to 25 by 15. If you cancel with 5 table, then it will become 5 by 3. So R3 by R4 is also 5 by 3, which means that Wheatstone bridge condition is satisfying. So as we know, if the Wheatstone bridge condition is satisfied, we can remove that R5, the middle part of the resistor. So we can remove this middle part of the resistor. Okay. Then the remaining circuit diagram, how it looks like means this is a remaining circuit diagram. This is 5 ohm and this is 1.5 ohm, and this value is 3 ohm, this is 2.5 and this is 1.5. This is 2.5 and this is 1.5, and it is connected to resistor 1 by 3 ohm, and it is connected to a battery of 1.5 volts with another resistor of 5.5 ohm. Now, if you take these two will be in series combination. So 5 plus 3, which is equal to 8. So, and these two are also in series combination, which is equal to 2.5 plus 1.5, which is equal to 4. So 2.5 plus 1.5, 0, 1, 4. So this is 4. So instead of these two, we can take 4. Okay, instead of these two, we can take 4. And instead of these two, we can take 8. So here we have 8. This is the 8 ohm resistor. And here we have the 4 ohm resistor. Now this time 4 and 8 are in parallel. Then what is the effective capacitor? I mean resistance in parallel means R1, R2 divided by R1 plus R2, which is equal to 8 4s are 32 divided by 4 plus 8, which is equal to 12. So 4 8 is 32, 4 3 is 12, which is equal to 8 by 3. So instead of again these two, we can replace with a single resistor of resistance 8 by 3. Okay, instead of these two, we can replace with a single resistor 8 by 3. Now 1 by 3, 8 by 3, 1.5, 5.5 all are in series. Then effective resistance this time will becomes 8 by 3 plus 1 by 3 plus 1.5 and 5.5, which is equal to 7. Then 8 by 3 plus 1 by 3. If you take 1 by 3 as an apple, 8 apples plus 1 apple, which is equal to 9 apples. So 9 by 3 plus 7, cancel 9 ones, 9 threes, sorry 3 threes are 9, which is equal to 10 ohm. So total effective resistance of this circuit is 10 ohm. So total effective resistance of this circuit will be 10 ohm. And what is the potential of the battery means 5 volts. Then we have to find out the current through the battery. Then current I is equal to V by R effective. So what is the total effective resistance means 10, and what is the potential means 5 volts. Then current I is equal to 0.5 amperes. This is the answer. So option 2 is correct. Now this is a question from current electricity, and we are going to do the next question. Question number 21. A bob of heavy mass m is suspended by a light string of length L. The bob is given horizontal velocity V0. It is given horizontal velocity V0. If the string gets slack at some point P, if the string gets slack at this point P, then tension at that point will become 0. So it is slack at point P. So at this point it will lose the contact, or else will lose the tension. So tension at this point you can take it as 0. Then they are asking making an angle theta from the horizontal. So it is making an angle theta from the horizontal. Then the ratio of speed V of the bob at point P to the initial speed. This is the concept comes under the vertical circular motion. And if you remember the shortcut formula for the velocity of the particle at any point, okay, velocity of the particle at any point. For suppose if I take this initial velocity as VA, I'll take velocity at this point as VP. Then we have one shortcut formula. Even we can do the derivation. Instead of that, directly I'll give the formula. Velocity at a point P square, which is equal to initial velocity square minus 2g, if I take length of this one as L, into 1 minus cos theta. This is the shortcut formula, and this is the angle theta. So if this is the angle theta and if this is the length L, at this point lowest point velocity is taken as VA, at any point velocity is taken as VP, then VP square is equal to VA square minus 2GL into 1 minus cos theta. So how we can do this derivation means we can do by using V square minus U square equal to 2A's formula. Here initial velocity is VA and final velocity is VP. Let us say it raised up to the height h. Okay, it raised up to the height h. And I'll take length of the string as L. 1 minute, I'll do it again. I'll take length of the string as L. Let us suppose it raised up to the height h, and I'll take this angle as theta. Then we can use this relation V square minus U square equal to 2S. Then final velocity is Vp square, which is equal to initial velocity is Va square plus 2gh, that is 2g into, sorry, it is going up, so minus 2gh. It is going up, right? So A will becomes minus g, minus 2gh. Then how to find out the h value is, we can find the h value like this. If I take the total length as L, from this length, substitute this, subtract this value. Then how to find out that value is, take the cos theta. Cos theta is equal to adjacent side, I'll take it as x. So that is x divided by hypotenuse, that hypotenuse is L. Then x equal to L cos theta. Then h can be taken as L minus x, that is equal to L minus L cos theta. So if you substitute this value, then velocity at a point P square is equal to velocity at the bottom square minus 2g into h value is L into 1 minus cos theta. Actually, this is the shortcut formula to find out the velocity at any point. Okay. So based on this, now I am going to do this problem. So if you can remember the shortcut formula, you can do it directly, or else we have to do this kind of derivation. So velocity at any point on the vertical circular motion is given by the formula Vp square. Okay, at any point is given by the formula Vp square is equal to, this is Va square, which is equal to at the bottom minus 2gl into 1 minus cos theta. This is the actual formula. And the theta should be taken from here to here like this. Okay, so this is the theta value. But in this case, this angle will be 90 plus theta. So you can write velocity at point P square is equal to Va square. That Va square is V naught square. Okay, that Va square is V naught square. So Va square is V naught square minus 2gl into 1 minus cos, this is 90 plus theta. Now cos 90 plus theta, 90 plus means second quadrant. In second quadrant cos is negative. Then we can say Vp square is equal to V naught square minus 2gl into, it becomes minus sin theta, minus into minus it becomes plus. So 1 plus sin theta. Take it as equation number 1. Now at the highest point, what is the tension means 0. Now tension at this any point, for suppose similarly if I calculate the tension at any point, mg is in downward direction, I'll take this as tension T, and this component of mg will becomes mg cos theta, and here one more force will be there, that is centrifugal force, which is equal to mv square by r. Then we have the formula tension at any point is equal to, okay, tension at any point is equal to mv square by r plus mg cos theta. Okay, so I hope you got this equation, mv square by r plus mg cos theta. Then tension at this point is taken as 0. If tension at this point is 0, which is equal to m into, at this point velocity is taken as Vp square by, and length r is nothing but length L plus mg into cos, once again theta value will be 90 plus theta. So theta value will be 90 plus theta. Cos 90 plus theta is minus sin theta. So therefore I'll bring this minus sin theta to the left hand side, mg sin theta. So you will get mg sin theta, which is equal to mvp square by L. Then cancel m and m. Then velocity at any point Vp square is equal to g into L into sin theta. Now by substituting this Vp square value here, you will get the value of V naught square. Then we will divide both. You will get the required answer. Now I'll take equation number 1. So from equation number 1, we can write Vp square is equal to V naught square minus 2gl into 1 plus cos theta. This is the value we got here, I guess. Fine. So from this we can say Vp square value, from this we can say Vp square value gl into sin theta, which is equal to V naught square minus 2gl, sorry, this is sin theta. So here we got the sin theta. From equation number 1, this is sin theta. So 1 plus sin theta. So if I multiply minus 2gl into sin theta, Bring this to the left hand side, then this value will be 3gl sine theta plus 2gl. I'll bring this 2gl to the left hand side, which is equal to v naught square. Then v naught square value, I'll take it as equation number 3, and this is equation number 2. Now divide equation number 2 by 1. Okay, so divide equation number 2 by 3. So if you divide equation number 2 by 3, 2 values vp square divided by v naught square, which is equal to vp square value is gl sine theta, vp square value is gl sine theta divided by v naught square. You can take a gl as common. If I take gl as common, this value will be 2 plus 3 sine theta. Then we can cancel gl and gl. Then vp by v naught, that is equal to sine theta divided by 2 plus 3 sine theta whole to the power of 1 by 2. This is the answer. So this is a little bit lengthy question as well as some difficult question. Actually, the NEET 2025 is the most toughest paper ever in the NEET history. So this is one of the difficult and time taken question, which is from vertical circular motion. And the next question, a 2 ampere current is flowing through two different similar copper coils having radius ratio 1:2. So ratio of the radius is 1:2. I will take R1 by R2 is equal to 1 by 2 or 1:2. Same ampere of current. So same 2 amperes of current is flowing through different circular coils. So this is the first circular coil of radius R1. This is second circular coil of radius R2. So same current is flowing in both the circular coils, which is equal to 2 amperes. Then the ratio of respective magnetic moments. So based on magnetic moment, this is the second question. So that magnetic moment formula I into A, that is equal to I into area can be taken as pi r square. Then magnetic moment is proportional to r square. Okay, magnetic moment is proportional to r square. Then we can say m1 by m2, that is equal to r1 square by r2 square, which is equal to 1 by 2 whole square, which is equal to 1 by 4, because 1 by 2 whole square is 1:4. So 1:4 is the answer. So this was the question number 22. And the next question, in some appropriate units, this is the problem from mechanics. In some appropriate units of time and position x, the relation of moving particle is given by t is equal to x square plus x, then the acceleration of the particles. Now listen, this is the question from mechanics. This is a question from mechanics, motion one dimension, mostly you can say. So x equal to t is equal to, they given the equation of time, that is t is equal to x square plus x. Now we have to find out the acceleration. To find out the acceleration, first I will take this equation t is equal to x square plus x, take it as equation number 1, differentiate this equation with respect to time, then we have dt by t is equal to, if you differentiate x square, we have 2x into dx by dt, because here the function is t and the element is x, plus next term will becomes dx by dt. Now what is dx by dt means rate of change of position. Rate of change of position is nothing but velocity. So we can say dt of t is 1, then 1 is equal to 2x into v plus what is this value means v. Then we can take v as common. If you take v as common, this is 2x plus 1, which is equal to 1, or v is equal to 1 by 2x plus 1. This is the velocity. Now I'll take this equation for my easiness, or I'll take this equation for my easiness. Once again I'll differentiate that equation. Then we have d by dt of 1, which is a constant, that is equal to, here two variables are there. One is position and another one is velocity. So we have to use the uv formula. Then 2x into dv by dt is the first term, and the second term will becomes v into d by dt of 2x plus, next if I take differentiation of the second term, that is dv by dt. So d by dt of 1, where 1 is a constant which is taken as 0, which is equal to 2x into dv by dt, rate of change of velocity is acceleration, plus 2 into, this is d by dx of t is nothing but d by dt of x is velocity, then velocity into, again here velocity is there, which is equal to v square, plus what is this means, dv by dt, which is nothing but acceleration. Now I'll take acceleration as common, then you can write 2v square minus 2v square is equal to, if I take acceleration as common, this is 2x plus 1 once again. So from these two terms, I'll take acceleration as common, that is 2x plus 1, bring this to the left hand side, minus 2v square, then finally we have to find out the value of acceleration, that acceleration a is equal to, you can write 1 by 2x plus 1 as v. So then 1 by 2x plus 1 is v, or 2x plus 1 is 1 by v. Then a into 1 by v is equal to minus 2v square, or a is equal to minus 2 into v cube, because if v goes to the other side, 2 into v cube. So this is the answer. So but the options is there like this. So then v cube means you can write like this, a is equal to minus 2 into, v is 1 by 2x plus 1. So this is 1 by 2x plus 1 whole cube. So option 2 is correct. So up to here we discussed 23 questions and we'll go for the next question. So before going to the next question, I'll do these questions in the part 2. So up to part 1, we discussed up to 23 questions. The remaining questions we'll discuss in the part 2.